So this is problem 4 from the last problem set, which is the moral hazard question for the dating thing, whatever that is. So I will not spend time on explaining the IRs and IC. Basically, if you write down the IR, write down the IC, it becomes these two things. So the interesting thing here is you have an objective like this. The objective is increasing in PI and decreasing in PN. So normally what we have is we minus WG minus WB, some kind of profit minus this times the probability. So normally both of them are decreasing in this objective, but now one of them is increasing, one of them is decreasing. So note when this happens, this one needs to be as high as possible, right? So if you think about it, if this as this PI goes larger, the utility of both the principal and the agent, both the mechanism designer and the person who is playing the game, both of their utility increase. Why do I just increase this as much as possible? So in this case, we know that when this increases, this becomes just larger and larger, so this will still hold mathematically. And when this is increasing at the same time. This side has 0.8, this side has 0.3, so this part increases more than that part, this side increases more than that side, so this is still okay. So both of them are still holding. We are making the principal or the mechanism designer's utility higher, so increasing this to the largest possible thing will be optimal, and the largest possible thing of this is 1 because there are probabilities. So that's because there's a physical constraint. So we bind it at 1. So that one for sure, I don't really need to care about anything. So the next thing is why Pn is 0. So Pn needs to be as small as possible. So one way to do this is just see Pn is small as possible, so we can decrease Pn so that we can make the first one binding. So the way to do this is the first one, IR, should be binding. But then when you calculate it, you will find that the IR is actually, in order for this to be binding, this Pn is smaller than 0. So there is a physical constraint again. Pn must be larger than or equal to 0. So basically what we want is Pn being as small as possible. So in order to make this binding, it needs to be smaller than 0. So it doesn't work. So the smallest it can be is 0. So that's why Pn is 0. So both of them, none of them are figured out from these IR and IC, so which means both of them are not binding, but it actually worked because this is actually the pair that maximizes our objective, because this one is as large as possible and this one is as small as possible. So